Hello everyone, I'm back with another video for you, and today we are going to focus on how can we multiply fractions. I think you're going to find fractions to be a little bit simpler than adding and subtracting. One of the major differences in that multiplying fractions is we don't have to find a common denominator. So that sort of saves us a little bit of work there. But there's a couple major things I want you to think about as we go through this today. I'm going to show you two different methods, and they are almost identical with one small change. Okay? The difference is when we simplify. In the first method, you're going to find that we simplify late, and in the other method, you're going to find that we simplify early in the problem. Other than that, everything else is going to be exactly the same. Okay, so let me try to break this down a little bit for you so that we know what we're doing. Okay, let's look at this first problem. It says 2/5 times 3/4. And don't forget that this dot here also means multiplication. I think that you will find as you go through middle school math and high school math, we move away from using the X a lot and we end up using the dot. So don't forget, this also means multiplication. Don't let that throw you. Okay, so when we're multiplying fractions, it's very simple. We are going to multiply straight across. So 3 times 2, you're going to find gives you 6, and 5 times 4 gives us 20. So far our answer is 6/20. Now, the same rules apply. We still always have to reduce and change improper fractions. And in this method I'm showing you, we are reducing at the end of the problem. And sometimes that works perfectly fine. So 6 and 20 is not improper. I don't need to change that. But both of those are even numbers, and they can be divided by 2. So if you divide both of them by 2, you get 3. And my bottom number, if I divide by 2, I get 10. So my answer to this problem is 3/10, because that is all the lower that it will go. So this one was a pretty easy one. Multiply straight across and then reduce. Okay, let's look at another one using this method. Okay, so let's look at this problem. We have 4/6, and we are multiplying it, according to our sign there, multiplication, times 3/5. So again, our same rules are going to apply. We are going to multiply straight across. So 4 times 3 would be 12. And if I multiply the bottom also, 6 times 5 is going to give me 30. So far my answer is 12/30. Okay, again, we have to simplify and change any improper fractions. Well, right now this is not improper, so I can skip that step, but I can reduce this. 6 and 12 are even numbers, so we could divide them by 2, but if we can find something bigger, that would be great. So let's think, what can go into both 12 and 30? Both of those numbers should be able to be divided by 6. I hope that's what you came up with. So if we divide by 6, you get 2, and if I divide by 6, I get 5. So now we look at 2/5. Can anything go into 2/5? No. So this is the lowest terms answer. Again, pretty simple. This is a simple method to use when your numbers are small. Like these were manageable, 12/30, and easy to reduce. Okay, but it's not always going to be like that. And so I want to show you the other method to use that when your numbers are a little bigger may be very helpful to you. Okay, now let's look at this problem. It says 12/15 times 9/18. Now, just by looking at this, you wouldn't think it's going to be that difficult. But if we multiply straight across, 12 times 9 is 108. And then if you multiply your bottom, which is 15 and 18, you're going to get 270. Now that's an awfully big number to reduce. So there is an easier way I want to show you, and it's the second method that we talked about there. What we can do to make life a little bit easier for us and save us some reducing at the end is we can reduce early. And when we reduce, we have to reduce a numerator and a denominator. So that means I could reduce up and down, like we normally would do it, or you could also reduce diagonally. Okay, so let's take a look at this. So let's look diagonally first, since that's something we're not used to. 9 and 15. I need to find a common factor that can go into both of them. Well, both of those numbers could be divided by 3. So I'm going to cross out 9, and if I divide 9 by 3, I get 3. So now let's make my numerator a 3. If I divide the bottom here, if I divide 15 by 3, now it becomes a 5. So my new bottom number is now a 5. Okay, so let's look diagonally this way. 12 and 18. We need to find a common number that could go into both of them. Well, we could do 2. That would work. So would 3, but we could also find maybe a bigger one. 6 could go into both of these. So if I divide by 6, that makes this number a 3. And if I divide by 6 here, that makes this one a 2. So we've reduced diagonally. Okay, we can also reduce up and down, which is why I have this arrow here. So let's check. 2 and 5. Is there any common number that will go into those? And no, there isn't. So let's check over here. 3 and 3. Well, both of those could be divided by 3. So let's divide by 3. So if I divide by 3, I get 1. And if I divide by 3, I get 1 here. So I think that's it. We've reduced diagonally and we reduced up and down. So there's nothing else we can do. So now we're going to do the same thing. Multiply your new numerators straight across. 2 times 1 is 2. My bottom number, or denominators, 5 times 1 is 5. This is not improper. And let's just double check. Could I reduce this anymore? Is there a common factor that goes into both of those? And no, there's not. So this is your lowest term answer. Okay, so it's very similar to what we did earlier. It's just that we're reducing earlier in the problem instead of later. And it helps when you're going to have a very large product here when you're multiplying. Okay, let's look at another problem using this simplifying early method. So 10 twelfths times 16 over 20. So again, I could multiply straight across, and if I do so, I'm going to get 160 over 240, again, which is a big number to reduce at the end. So to save us a little bit of time, we're going to reduce, and we can reduce diagonally. You need to reduce a numerator and a denominator, or we could do up and down like we normally do. You may not reduce across because that's not a numerator and denominator. It's only up, down, and diagonals. That's it. Okay, so let's find something that we can reduce to make our numbers smaller. So let's look, and you may look up, down first or diagonal. Does not matter to me. Let's do diagonals. 12 and 16. Well, those could be divided by 2. Let's do that. So if we divide by 2, 16 divided by 2 is 8. 12 divided by 2 is 6. Well, I look at 6 and 8 and think, man, those could be reduced again. So I probably could have used a bigger number earlier, but we can still reduce. 6 and 8 are still even. So let's divide by 2 again and get a 4. And if I divide by 2 again, this is now a 3. Okay, 3 and 4, nothing can go into them. So I'm done going diagonally this way. Let's check the other way. 10 and 20, well, we could do 2, we could do 5, but remember, they end in zeros. So we could divide them by 10. So 10 divided by 10 is 1, and 20 divided by 10 is 2. Okay, so we've done diagonally. Let's multiply across now. So 4 times 1 is 4, and the bottom, 3 times 2 is 6. So I've got an answer of 4/6. And if we look at that, those are even numbers. So that means we could reduce again. It's not improper. I don't need to change that, but I can reduce those. So let's look back here for a second. When I reduced diagonally, I forgot to look up and down. So 1 and 3 can't be reduced, but 4 and 2, I probably could have divided those by 2, and then this would have been smaller. But that's okay. As long as you catch it at the end that you could have reduced this again, that's fine. So both of these numbers can be divided by 2, and I get 2/3. 2/3 is as low as it can go and cannot be reduced. So it's okay if during your reducing within the problem, if you miss something. That's perfectly fine, and it's going to happen. Just double check your answer at the end and make sure that you've reduced it. Okay, I have one more problem I want to show you. Okay, guys, we have one last problem to look at here. And this one says 8/12 times 4. All right, so this one looks a little different from the other ones because we have a whole number here of 4 instead of a fraction. Okay, in order to multiply, we need to turn 4 into a fraction. Okay, so let's think about that. How can I make a fraction worth 4 wholes? Okay, well, the common mistake people make is they want to put 4 over 4. And 4 over 4 is not 4 wholes. 4 over 4 equals 1. So that is not equal to 4. So do not put it over 1, please. Okay? In order to turn 4 into a fraction, we have to put 4 over 1, right? Because if I were to divide 4 divided by 1, I would get an answer of 4. So that means 4 over 1 is equal to 4. Once you do that, now it's back to just like we normally did. We could multiply straight across and reduce at the end, or we could reduce early. I'm going to reduce early here. We could do it up, down, or diagonally. Let's go up, down this time, how we've always reduced fractions. So 8 and 12, we could divide by 4. So if I divide by 4, I get an answer of 2. And if I divide this one by 4, I get an answer of 3. Now that we've done that, I can't reduce this one diagonally because it's already 1. So let's look this way. Let's check our diagonals. 4 and 3 cannot be reduced. They're as low as they go, and so are 2 and 1. Okay, so we're done. So let's multiply straight across. 8 is what we get. 4 times 2 is 8, and the bottom, 3 times 1 is 3. Okay, so now we've run into what we know as an improper fraction, right? We can't leave it like that. We've said that when we were adding, we said that when we were subtracting, the same rule still applies. So we have to change 8/3. So you remember how to do that. We do 8 divided by 3. And I know some of you can do this in your head. That's great. It'll go twice. That's 6, and you will have 2 left over. Right? So my answer here, you have 2 wholes. Denominator stays the same. And our remainder here is your numerator, 2 and 2/3. Double check. Can 2/3 be reduced? No, it cannot. So you are done. Sorry there. Okay. So when we are multiplying fractions, you may use either method. You may multiply straight across where you're simplifying late in the problem. That's perfectly fine. Or you can use the method that I just showed you in which you simplify early. It doesn't matter which one you use as long as you remember to always reduce the fractions and change them if they are improper. Okay? Good luck with this and message me if you have any problems. Have a great day, guys.